This is our Maple 2019 What's New for Education and Research. So in this video, we're going to be talking about a lot of new features, and you'll be seeing that a lot of this really kind of focuses kind of mainly on the mathematics. And accordingly, I'm going to be starting off by showing you a number of examples that are probably enclosed within this advanced mathematics heading. But I think in general, you can see from this is just our overview here of Maple 2019, there's a lot of new functionality that really will span all of mathematics or engineering, science, technology, wherever you're using Maple today. So I'm only going to show you a small fraction of this functionality, kind of some of the highlights, but there's certainly a lot more to explore. So certainly when you get inside of Maple, just go up here to the Help menu, click on What's New, and you're going to see a lot of really great content. But to begin, let's start with a couple of examples from advanced math. And where I actually want to take us to begin with today is I want to look at a couple of examples where some of the core functionality in Maple, kind of some of the commands we're using on a daily basis, the end command, the solve command, the simplify command, I want to show you places where they've just improved. They return results they weren't returning before. They're returning better results than they were in previous releases. And I've just got a selection of problems here. So let's, without further ado, just jump right into those problems. And we'll start with a simple integral here from 0 to pi of the absolute value of x squared dx. So in Maple 2018, this actually did not return anything, and in Maple 2019, it does. That to me is always exciting news because they're solving different types of problems. Let's do another integration problem. So int of 1 over ln of t is going to range from 0 to x. We're going to use a couple of options for int here as well. So we're going to do all solutions. We're going to do Cauchy principal value as well. And in Maple 2019, we'll actually see that we actually do get an additional clause here. We're actually seeing that in comparison here with Maple 2018 on the right side of your screen, we're seeing that we're hitting this additional value here of minus infinity at x equals 1. So we're seeing kind of a discontinuity, or we're seeing an asymptote happening at a certain point. All right, accordingly, we'll keep rolling through here. So solve, and here's another example where in 2018 we returned a pair of results here, but now in 2019 we're actually seeing this additional point here of x is less than minus 6. Here's some simplification problems. So here's a case where simplify in Maple 2019 was not returning the right solution. Now we're returning 0 in this case. Int trans Fourier. Here's a case, we run this, we'll get back an actual result. So in previous releases, even if we returned a result, we could combine it, but we were still getting it back in terms of Fourier. So in this case, we're able to actually go through and get a result returned to us. And PDs. PDs are always a big strength for Maple. Here's a case where in Maple 2018, we didn't return a result, but in Maple 2019, we do actually return a result from running this PD. So a lot of these problems, they're contained within the advanced math page. As I said before, if you go up to help, what's new, click on advanced math, or in the case of the PD stuff, you'll see that on the PD and boundary conditions help page, what's new page. So either one of those places, you go to those pages, you're going to find a lot of more details on these problems. But I only have a limited amount of time, so let's keep rolling. I want to show you some more applications. Math apps. So I talked before about it's mainly about the math, right? I'm showing you some examples of solving the math. Let's talk about ways of visualizing, exploring the mathematics, and even some applications of mathematics. And a few of the ones I want to show you today. Let's start with something rather basic. Let's start with a math app here for triangle perimeter. And this is a regular Maple math app. We have a problem we want to solve, and what we have is some interactive interface to it. So in this case, I can drag out the corners of this triangle, and what you see on the right side of your screen is all the line segments, AB, BC, AC. They're changing in real time as I'm changing this point around. So this app is pretty simple, but what it's doing is if you have a student exploring, just learning about triangle perimeter, they can just drag this around and see how these values are changing. They can grab the whole triangle and move it around as well, just to see how the values would change, and this distance between 2 points formula is used to calculate these values. So simple problems, simple solutions. We're trying to show you, we're trying to kind of get you closer to the solutions, get you a little bit more conceptual understanding of the problems. Let me show you a few because we really specialize in this release on some applications for computer science. And here's a new application called the Introduction to Big O Notation. I won't cover the details here. This is the concept section. But with any math app, these are completely editable. So if you did want to use this in a classroom, just uncheck or add a checkbox here for editable. Then you can go up here and you can modify this application as you see fit. All right, so this application here, what we see here is we see some controls. We can add in different orders to our graph, and what we now see is these lines and how they intersect. Now, this doesn't show you a lot unless you really start playing around with constraint view. So let's zoom down to, say, constraint view with one element. And now, say, if you were just having this amount of information, maybe we wouldn't think about, this red line here overtaking the burgundy line above. But if we do start playing with constraint view, we can quickly see that, okay, there's a point where these two lines intersect here with 4 elements. Or if we go past that, we see that the red line obviously overtakes the other line. So when we start experimenting, when we start using these interactive apps, we can start giving a little bit more understanding or kind of letting students explore different topics in different ways. So big O notation, that's a fun one to just kind of experiment with the complexity. Let me show you a couple more here. I'll show you a binary search tree as well. So here we can insert some values. And I'm just going to go through here and throw in a couple different values. And let's go 10, insert. We kind of see how this tree is self-balancing. That's because we have this option indicated. Now let's go through here now and just put in 3 in our search field. And we'll see as we walk through that tree. Search for that term, we'll put in 10, search for it, walk through it. And we can also traverse the tree, pre-order, in order, post order, and so on, and return that ordering. So it's all very interactive, you kind of just put in values and start working away. The last one I'll leave you with is a sorting algorithms app. Similar to the others, we have some exposition here. We walk through the problem. In this case, we say here's bubble sort, time complexity, and a quick implementation inside of Maple. We scroll down below, and then we can say choose one of the sorting algorithms, generate some random values, and then we can watch as Maple visually shows you how the sorting algorithm will work. So we can kind of look through this, we can kind of watch, try to get some understanding to see how sorting algorithms actually would be visualized rather than just looking at an algorithm on paper. So very quickly, that's just a couple. There's more that have been checked into this latest version of Maple, and of course there's even more in product. There's almost 500 different applications which were designed for education, and we certainly encourage the use of these in the classroom, and we are always working on adding more of these. You'll see more of these being added to our Maple Cloud on almost a daily basis. But at this point, let me move on, and I've kind of now been talking a little bit about the student experience, getting a little bit more out of Maple by showing you interactive demonstrations. Let me talk about more resources we've added specifically for students. And I'll start with talking a little bit about our student packages. So in Maple, we have a number of student packages. There's student numerical analysis, which I just loaded. There's student calculus 1, student linear algebra, student statistics, and a couple more. So each one of these is designed as kind of an environment for teaching and learning each one of these subject areas. And what we've done for each one of these is we've made sure that if there are commands, if there are visualizations available for these packages, that they're also available within our context menu system. Now I've entered in here 5.3, 5.5. If I go over here, hover over here, this will open up my context menu. I'm just going to click and pin this open. And what we can see now with the context panel open is we can go down to the bottom. We've loaded student numerical analysis, and we can start using commands from that package through this clickable interface. So let's do absolute error for these two values. Let's go back again. Let's do relative error. Let's go back again. Number of significant digits. We can kind of just explore, just experiment. Let's do one more here. So here we have a list of lists. We've got some points here. Let's click on the output, go back to student numerical analysis. Let's interpolate this using cubic spline. Variable name here is going to be x. Okay, and this returns a poly-interp structure. This looks a little bit opaque, but what we can actually do with this is a lot of different things. We can look through this list here, and let's just say return the interpolant. And this gives us back the interpolating piecewise function that we see here. So here's the command. We've done all this very clickable through the context menu. So this is something that we didn't have in Maple 2018 for student numerical analysis, and we've certainly expanded what you can do with any of the input for student numerical analysis through the context menu system. So just down below here, we see a number of examples. Here's a case where we've input a matrix, And we can do something similar. We have a matrix. We can perform a number of different operations, leading principal submatrix. We can type in sine of x. We can get the Taylor polynomial approximation, and so on. So there's a lot of these clickable tools. So this is more for a student if they're opening up Maple today. They just want to experiment. They don't want to have to learn the Maple language too much. So they can just use the clickable tools in order to get a little bit further along in the mathematics. All right, so practice sheet. This is a new functionality that was added with Maple 2018, but what we've done for Maple 2019 is we've added a new interactive assistant. So if I go up here to Tools, I'll go down to Tutors, Basics, and this is similar to what I was saying before about student packages, that these subject headings here match up with our student packages that we have inside of Maple. I'll go under Student Basics, Practice Sheets Assistant. And this is this new Practice Sheet Assistant. It allows us to build out things like, hey, let's do some expand problems, and range minus 10 to 10. We'll leave everything the way it is, and let's just scroll down here and let's generate. Oh, number of variables has to be greater than 0. Let's turn up variables to 1, and now we have the expansion practice. So the idea here is that a student would come in and say, okay, here we have x minus 3, x plus 0. So let's start by x squared and minus 3x. All right, I'm just going to zoom out to get this on the screen. There we go. And the idea here is you would just check my work. I get this one wrong. I haven't put anything in here at all for the rest of them, so I'll just get all those wrong. But we can click a new sheet to do some new problems. And this is just a practice sheet. We're just practicing different types of problems. But the key builder here is that this practice sheets builder, it just lets you very quickly build different practice sheet variants. So you can see here we have addition, subtraction, multiplication, division, factor, expand, and solve. All different variants of operations. And you can kind of build out custom practice sheets that you would then share with a student. So the student would get this practice sheet and they would just do this for practicing different problem types. All right, so I've already talked about the math apps. I won't go back there, but I will very quickly mention that we have done a little bit of reorganization as well. You'll find a lot of the different student tools are now all featured under this tutors menu. So you'll see tutors, basics, pre-calculus, so on and so forth, including now optimization and statistics and so on. So we've just moved a lot of the resources down into this tools tutors menu. All right, so the next thing I wanted to talk about was building interactive plots. And specifically, I want to talk about using the interactive plot builder to build animations. So I'm going to do a couple of examples here, a couple of quick examples. So let's start with sine of t times s squared. So I've entered this into Maple, and I'm going to just go over to our context panel. I have this open. As a reminder, if you don't have it open, just hover over this button right over here. But I'll now click on Plot Builder. This brings up our Plot Builder window. It changes out the entire context panel system. And very quickly, going back, if I just wanted to do a quick 3D plot of sine of t times s squared, I would just click on 3D plot. And this would allow me to customize, change the look and feel of this surface, color scheme, and so on very quickly. But what I want to do now is I want to show you the new functionality, which is that we can make animations. So if I click animation, this will change out the list of the plot variants that we have available to us, because now we're assuming that one of these two variables, either t or s, are an animation parameter. And by default, it will say now it's going to make a guess. It's going to say, okay, I'm thinking that we want to animate over t. So we can now use t as our animation parameter, but you can see that these are drop downs, so we can switch these at will. But we'll animate from 0 to 10 for the value of t. S is going to go from minus 2 pi to 2 pi. And I'll click on Build Animation to see how this works. So as we're now animating for different values of t, we see S on the x-axis here, or the horizontal axis. We see how this curve is changing. And we see it kind of up at the top here, we're seeing different values from 0 to 10 of t. Now let's flip this around. Let's instead animate over S. This is the kind of the power of being able to use this tool. And let's build the same animation. We can now see different values of S from 0 to 10, and we can see how that changes the curve. So this plot tool, this plot builder, it's really allowing us to get a little bit deeper into this expression. We can see how either t or s impacts the results of whatever we have within this expression. I want to do one more example for building interactive plots. In this case, I'm going to do a 3D curve. I've got this parameterized in the following way. So we have x, y, and z values. So cos of t, sine of t, 2 plus sine of a times t. So we have our animation parameter here of a, and we're parameterized over the t value. So I've got this typed into Maple. Let's now again go over and choose Plot Builder from the right side. This will swap out our context panel. And if I click here on animation, we now only have one option, which is to draw a 3D space curve. And by default, again, it's made a choice for us for the animation parameter. It thinks that the animation parameter is t, but in fact, we want it to be a. So let's go from a from 0 to 20. We'll just change some values here, and we'll go from t, we'll change it from minus 2 pi to 0, so 0 to 2 pi. And I'm just going to make the line a little bit thicker. That way the animation shows up a little bit better. And let's build this animation using the Build Animation button, and then we'll play this back. And let me just loop this around so we can watch this oscillating a little bit here. So the plot builder, it can do all different types of plot variants. It kind of is it's an interface for a lot of the Maple plotting language. So you just type in an expression, and in this case we typed in a parameterized expression. We can do a 3D curve, but you can type in all types of different expressions and just use the plot builder to visualize, to kind of get a little bit deeper into the mathematics and understand how different expressions perform or vary when you vary certain parameters in the expressions themselves. Now I don't want to leave visualization behind quite yet. I want to show you a couple more examples. And let me show you a new command. It's called Plot Tools Polygon by Name. And what I'll first do is I'm going to just define a list here of some different shape names. This isn't all the shape names we have available to us, but I'm going to do a plot here. We're doing plots display of a sequence of plots, and we're just pulling some colors out of our Color Tools Get palette of the HTML palette. And what we can see here is we can see a circle, a semicircle, ellipse, rectangle, stadium, half stadium, indent stadium, super ellipse, and a super circle. So this is just kind of a little bit of fun code just to show you some of the new functionality we have with this Polygon by Name command. To just run this on one option, so we'll run this on the rouleau hexagon. So we'll do Plot Tools Polygon by Name of rouleau hexagon, color linen, and we return this. So this command is really designed for just generating shapes based on their name. So it's another new one, Polygon by Name. If you're looking to get more information, of course, you can, at any point in Maple, either just go up here to our help search, type in Polygon by Name, and that'll come up in our help system. If you've already got the command typed out, you can press F2 on your keyboard, and that'll open up a help page for you, where you can learn a little bit more about the command that you see there. So let me show you a couple more changes for programming, just for fun. And this is a neat one. This is one kind of that if you've ever coded in C, this will be very familiar. So Maple now supports C-style increment and decrement operators. So previously, say you had a variable n, and we wanted to increment n by 1. We would type in n colon equals n plus 1. Right? This is the way we usually operate in Maple. And with this release, we can now do n plus equals 1. We can do plus plus n. We can do n plus plus. And this will all increment that value of n. So, of course, we see here this is shorter to type, obviously, but and there are some cases where we're actually computing lists based on the size of the previous list. So say here we wanted to make A, and what we're doing instead of A is we're trying to grow it in some way. So we're maybe performing some expensive operation, we're doing some other call to some other command, and trying to grow it by expensive operation is equal to A expensive operation plus 3. What we're doing here is actually a lot more efficient than making these multiple calls to expensive operations to grow things. We can literally just do the plus plus in order to increment by 1. So this is a little bit different than or increment by any arbitrary value, actually. So this is certainly a better way of approaching the problem, and the reason why this is less expensive, of course, is that we don't call this expensive operation twice. We're just doing one call and just incrementing. So increment and decrement operators, we can do n is equal to 1. We can do, let me just go back here and change this. We can do minus minus, that'll decrement it as well. It's just kind of some new ways of working within the Maple coding language. So Maple language has been around for a long time, and we're always trying to find ways of making it a little more fresh, adding in some of the influences that we've seen in the Maple language for some time. So a couple of more problems to show you. Signal processing. Let me first define a vector. And I'll show you the result here, actually, because this is a 27 vector 27 element vector. And this is actually the new way that we do show our table structures inside of Maple 2019. So previously, if you had anything that was larger than 10, either row or column, we would just show you a summary for that data structure. And now within Maple 2019, we're going to show you the first 10 rows, 10 columns, as well as the size of the container. So this is kind of just a nice way of being able to see very quickly what the information looks like and then what the size of the data structure is. So not to get too far into that, but the new command we have in signal processing is called find peak points, and the way that this works is it'll go through something like this 27 element vector and it'll look for peaks and valleys. So what we see in this plot is we've detected the peaks in each one of these cases, and we can of course customize this. There's a whole bunch of different options to peak points to kind of work away with this heuristic, but in this case we can just see some of the peaks. We can do peak detection. It's an exciting new command, and there's actually a lot more for signal processing I won't be covering today, but again, you can go into what's new, signal processing, and actually signal and image processing. There's a little bit more here. And you can find out a little bit more of what we've been working on for the last year. You can see that there's frequency spectrum for regularly sampled data, there's find peak points, spectrogram, real and complex spectrum, FFT shift. There's a lot of new functionality we've added for signal processing. But I'm going to start wrapping up. I'm going to start talking about some of the interface changes. And as you just saw a second ago, the display of data structures has changed. So if we do something like a matrix command, matrix 2020, and in this case we're going to fill it with random variables, random numbers, sorry. The matrix itself is now displayed. Previously we would have just shown you a summary, but now we actually see the first 10 rows and 10 columns, as well as right below that we see the dimensions of this matrix. So this to me is kind of one of my favorite changes inside of this latest release, because this allows us very quickly to get an understanding of what type of information we have in this data structure, and most importantly the dimensions. Like, this is just the information that I use most frequently. So of course this can be customized. We have our table interface, our table size is an interface option that we can customize the size of our tables we show. But in general, we just find that this is a great way of very quickly showing you that summary of the information, so then you can go on and use it in different ways. And I'll also mention Audio Tools Read. Here we're doing another reading in a data file, an audio file. And the summary for that, it looks even a little bit different than what you saw for the other matrices. So in this case, we're actually just showing the important stuff. So if we read in an audio file, we'll see sample rate, bit depth, channels, points per channel, and duration. So we're showing you just kind of the information that you need to work with the data. All right, a couple new features. Units by dimensionality palette. Let me open up a new document here and show you the units by dimensionality palette. I'm going to go over to our palettes here. You'll see units. And this units by dimensionality palette has actually replaced two previous palettes. They were called units FPS and units SI. And what this allows you to do is quickly do 2 feet plus 3, let's do 3 centimeters, we'll say. So very quickly you can enter in different units of different dimensionality types. So here we had length. You can do force, frequency, energy. There's a whole ton of units here. So there's a lot more than what we had with the previous units palettes. And of course, these then work with all of the rest of the tools we've been working on for the last few years. If we click on 2 feet plus 3 centimeters, go over here and choose a unit, we can then convert this to, say, an angstrom and get a result back in a common unit format. So we have all the units formatting within the context panel. If again you don't have that open, just go over here and click it, and you can do custom unit handling all through these controls. Favorites palette. So this is one that we've had in Maple for a long time. I'm going to come over here to an empty document again. So we see within the favorites palette, I've got a couple of different elements here. What we can do in Maple 2019 is you can now drag these around in order to reorder. So this was a very frequently asked for feature. We finally got around to adding into this release of Maple. So now you can do all types of custom input through the favorites palette and make sure your favorites palettes are being organized accordingly. Plot export, we can now export plots to SVG. That's, again, very frequently requested feature. And one thing I did want to spend some time talking about is experience on startup. I think this is one of the most important parts of your experience in Maple. If I click on the Start button here, this is what you'll see typically when you open up Maple for the first time, the Start page. And in previous releases, we had a lot more here. We tried to kind of show you all the categories of how Maple was applicable and so on. But in this release, we really pared this down to the fundamentals. Right? We show you how to get into Maple's documentation. If you're interested, we show you what's new. We just show you very quickly here's how to make a new document or a new worksheet. But then we get into kind of the most frequently used stuff inside of Maple. The math apps. Here's a list of packages so you can see the functionality we have available for you inside of Maple. Here's a plotting guide. If you're not using the plot builder, then you can go into the plotting guide and see what customizations we have for visualizations. Of course, you can also click on the Maple Cloud. This will give you access to actually the online Maple Cloud, which you could also get access to by clicking up here on the sign-in button and getting into your various groups or viewing the public math apps groups. Startup experience is important though, because we want to make sure that even for a new user, we are making them productive from day one. So if we expand this button here, this will give us a whole bunch of resources which are great for new users. So here we have a video you can watch to get started with Maple. You can browse more videos. You can get into our Quick Start Guide, our Maple portal, our engineering portal. There's our user manual, our programming guide, and our applications are all featured here. As well, there are links to our user forum. You want to go ask a question, or if you want to email our tech support, these are all available now very quickly and directly through our Start page. So this will be by default what you see inside of Maple when you open it up. Again, if you don't want to see this, you can also just click here, don't show this page on startup, and then you'll just get either a new document or a new worksheet depending on what you have as your selected preference. So I'll leave it there. I'm going to click here again on what's new in order to bring up the what's new page. There's a lot more I haven't covered in this demonstration today. We'll of course be featuring more features in our YouTube channel over the next coming months. We're going to be recording a lot of new features. You'll also see a lot of blog posts on our user community forum. So that's mapleprimes.com. We'll be talking a lot about Maple 2019 in the coming months. We want to make sure that we kind of get out there. We want to advocate for all this great work we put into this release, but we also want to make sure that we're getting your feedback on it. So please take part, join in all of our social channels, ask us questions, use the new features, and get in touch with us if there's something that you'd like to see in the next version of Maple, or if there's something you'd like to see changed in any one of the commands that we have added. So that does it for today. Thank you for joining us, and of course, check out a lot of the new videos inside of our YouTube channel tomorrow. Thank you very much.